In this problem, we're going to examine the relationship between a titration and equilibrium. You have 100 milliliters of a solution containing 0.2500 molar of acetic acid. So it's giving you the concentration of acetic acid, which is a weak acid. And to that, you're adding an equal quantity of 0.2500 molar sodium hydroxide. So the first thing you have to look at is the titration of these two things. So let's write the titration equation. Acetic acid is HC2H3O2 plus sodium hydroxide. It's going to react in a 1-to-1 ratio to give you water plus some sodium ion plus some acetate ion. Now, the acetate ion is going to be very important in our subsequent equilibrium, so I'm going to go ahead and highlight this. Well, it would help if you could see it. Maybe I'll just circle it, and then that way you can still see it. Now, we need to figure out how many moles of that acetate we're going to have when we're finished. So we're going to take 0.100 liters, I've changed the milliliters to liters, times the concentration of this 0.2500 molar to get 0.02500 moles of acetic acid. Now you're adding an equal quantity of sodium hydroxide, so the math doesn't change. So in this problem, you have 0.02500 moles of both acetic acid and sodium hydroxide. Since this reaction is 1-to-1, you're going to produce the same amount of acetate. Whoops. Now, the important thing is to calculate the concentration of the acetate ion. Now that you know how many moles there are, you're going to simply divide that by the total volume, which is 0.200 liters. And that's going to give us a concentration of 0.1250 molar. Now that we know the concentration of the acetate ion, we also know that it sets up an equilibrium, and we can go ahead and write that equilibrium expression from the equation. So we have acetate reacting with the water to establish an equilibrium. Yeah, that was right. According to its Kb. Now, the problem gives you the Ka of acetic acid, so therefore you need to know the relationship between the Ka and the Kb. If you multiply those together, you're going to get the Kw of water, which is a constant value, 1 times 10 to the negative 14. So we just have to plug in the Ka, 1.770 times 10 to the negative 5 times the Kb is equal to 1.0 times 10 to the negative 14. Oops. Okay, now solving for the Kb, we get, let's see, 5.65 times 10 to the negative 10. Now that we know what the Kb value is, we can go ahead and write the equilibrium expression for the Kb and substitute in what we know. The Kb is going to be equal to the concentration of acetate. Remember, it's always concentration of the products times each other over the concentration of reactant. So now we just need to substitute our values in. We have the Kb, so this value is going to go right there. We have the concentration of acetate ion from the prior problem solving step. It's going to go down here. And that leaves us with this acetic acid concentration and the hydroxide concentration expressed as X, because this reaction is 1-to-1. So you're going to get the same amount of each one, and we're going to let that be our X. So when you plug it in to the formula, you should get 5.65 times 10 to the negative 10 is equal to X squared divided by 0.1250. X, solving for X, you should get 8.40 times 10 to the negative 6 molar for both the acetate, or I'm sorry, the acetic acid and the hydroxide. Now the hydroxide, that's what you really want, because that's going to give you the pH of your solution. So now all you need to do is take the negative log of that hydroxide concentration and subtract it from 14. When you do that, you should get an overall pH of the solution that is equal to 8.92.